Fine. In continuation with the previous lesson, that was areas related to circles. In the last class, I had given you the formula. Hope you remember, right? And you have learned also. And if not also, you may just go through it once, right? If you constantly practice, you will memorize it as well, right? So we have taken up one question. In the given figure, arcs have been drawn of radius 7 centimeter each. In this figure, we have drawn these arcs. These arcs are of radius 7 centimeter. All are of 7 centimeter radius each, with the vertices as A, B, C, and D. So taking this vertices as A, B, C, and D, we have drawn 4 arcs, right? We have to find the area of the shaded region. Now this portions we have shaded it, right? We have shaded the portion. We have to find the area of the shaded region. So let's say if I write this, let's say this theta is theta 1. Okay, the angle which is made at the vertex A, I'll take it as theta 1. The angle which is made at vertex B, I'll take it as theta 2. Likewise, here this will be theta 3 and this is theta 4. Clear? So now, what is the area of the shaded region? Area of shaded region. Now, each is what? Each is a sector. Each shaded portion is a sector whose radius is how much? 7 centimeter. Whose radius is 7 centimeter. So I'll write area of shaded region is equal to area of sector 1, area of sector 1 plus area of sector 2 plus area of sector 3 plus area of sector 4, right? There are 4 sectors. Now what is the formula to find area of each sector? This will be theta by 360 into pi r square. But because we are taking sector 1, so theta is what? Theta 1. For sector 2, this will be theta 2 by 360 into pi r square. Likewise, theta 3 by 360 plus pi r square, and this is theta 4 by 360 into pi r square, right? It looks long, but it's the simplest one. Very simple. See, what is common here? This pi r square upon 360 is common. Pi r square by 360, pi r square by 360 in all the sectors, that is common. So what is left with us now is theta 1 plus theta 2 plus theta 3 plus theta 4. Correct? Yes. Now we know that sum of the interior angles of a quadrilateral, theta 1 plus 2 plus 3 plus 4, these are the sum of the interior angles of a quadrilateral. How much it should be? 360 degree. 360 degree. So we'll substitute the values 22 by 7 into radius. That is the length of the arc, right? Sorry, the radius of the arc, right? How much is it? 7 centimeters. So this 7 into 7 divided by 360. And the sum of all this theta is also 360. Clear? So this 360 and 360 will divide. 7 and 7 will divide. What is left? 22 into 7. 7 into is 14, 7 into is 14, 115. 154 centimeter square. Clear? Next question in this figure, what is given? A circle with the diameter BC, right? And there is a triangle ABC which is inscribed in the circle. And then we have this triangle, quadrant BOD. We have to find the area of the shaded region. Clear? The measurements are given. AC 24 centimeter and AB is how much? 7 centimeter. We have to find the area of the shaded region. Clear? The radius of the circle is not given. In the given figure, O is the center of circle, right? O is the center of the circle. AC, this length is 24 centimeter. AB is 7 centimeter. And angle BOD is equal to 90 degree. We have to find the area of the shaded region. Right? You have to find the area of the shaded region. So first of all, in class 9, what we had done, angles in the semicircle is 90 degrees. See, this BC is what? It is the diameter of the circle. Right? Diameter of the circle. So this diameter is subtended in this angle A on the circle, right? So this angle will be 90 degrees. Simply we'll write angle in a semicircle is 90 degree. Okay. This AB is the diameter and above this, right? This is a semicircle. So this diameter is making 90 degree angle on the circle. Clear? So now we need to find the length of the diameter so that we can determine the radius of the circle. Any guesses how we can find the diameter of the circle? By using Pythagoras theorem. In triangle ABC, we can use what? Pythagoras theorem. Because it's a right angle triangle, the base and perpendicular is given. We need to determine the hypotenuse. We need to find the hypotenuse. So what is the hypotenuse here? BC. So BC square is equal to what? AB square plus AC square. Right? AB square plus AC square. So what is AB? 7 square. What is AC? 24 square. 7 square? 49. 24 square? 576. Right? When you add it, you will get 625. BC square is 625. So what is BC? Can I write BC square is equal to 25 square? Right? Because the square of 25 is 625. Clear? Now taking square root both sides, what will you get? BC is equal to 25. If you take the square root on both the sides, then square and the root will get cancelled, right? You get BC is equal to 25. So what is BC? BC is the diameter of the circle. BC is what? Diameter of the circle. Then what is the radius of the circle? Radius of circle is equal to what? 25 divided by 2, that is half of the diameter. I'll not write in decimal. You also avoid using decimals. It will be time consuming for the calculations during the exam. See, yesterday I was telling also that you have to manage time in exam. You have to manage time. So you have to use all possible ways where you can save time for calculation. Right? So now area of shaded portion. Area of shaded portion is equal to, how will you find the area of this shaded portion? I'll mark this as 1 and this as 2 and this as 3. So area of shaded portion is equal to area 1 plus area 2 plus area 3. Now area 3 is quadrant, that's fine, understood. But how will you find the area of 1 and 2? 1 and 2. Any idea? Area of semicircle minus area of triangle. From the area of semicircle, see, from the area of semicircle, we'll subtract the area of triangle. From the area of semicircle, we'll subtract the area of triangle. So for these two areas, clear or not clear? This is equal to area of semicircle minus area of triangle ABC plus, right, plus this will be area of quadrant. Any doubt? Plus area of quadrant. Now what is the area of semicircle? This is pi r square divided by 2. Area of triangle, half into base into height, plus area of quadrant, pi r square divided by 4. Any doubt here? This is half circle. This is 1/4 circle area, half circle का area, 1/4 circle का area, and then we have minus half into base into height. So half plus 1/4 is how much? 3/4? 3/4? But I'll show you the calculation part also, okay? This is pi r square by 2 plus pi r square by 4 minus half into base into height. The LCM is what? 4. 2 into 2 is 4. So this will be 2 into pi r square, 2 pi r square plus pi r square minus half into base into height. So I should be writing it here. Okay. One more step. This is 3 pi r square by 4 minus half into base into height. Fine. Now this will be 3 into 22 by 7. Right? 3 into 22 by 7. Pi value. What is r? 25 divided by 2. This is 25 by 2 into 25 by 2 whole divided by 4. I'll write here 3 by 4. Clear? And then is half into base into height minus half into, for this triangle ABC, we'll take the base as AB and the height as AC. So it will be 7 into 24. Now simple calculation. Okay. 2 into 1, 2 into 12. 2 into 1, 2 into 11. So now what is left? 3 into 11 is 33 into 25 into 25, 625. 4 into 7 is 28, into 2 is 56, minus 7 into 12 is 84. Fine. Now you tell me, what did you get out here? 20625 divided by 56 minus 84. So after dividing this 20625, what did you get? 368.30 minus 84. So after subtracting, you will get 284.30 centimeter square. So this is the area of the shaded portion. Okay, we'll be doing this much for today. We'll continue in the next class, right? But please practice the same sums, right? Practice the same sums. You may take up some extra questions as well, right? Practice, please practice on a regular basis. Very, very important. You have hardly any time left for exam. I'm not talking about the internal, even the external, I mean the board exam. You have hardly any time. You have less than 6 months time. Is it clear? So please start preparing. So this much for today. Thank you.